Welcome back to the deep dive. Today we're cracking open a really specialized manufacturing document from EBOC.
We are. It pulls back the curtain on the technical rigor
Yeah.
behind how they actually build their e-bikes.
And our mission here is to really give you a shortcut, to uncover how all this intense, almost lab-grade quality control.
Is tied directly to, some massive global market advantages.
Right. This isn't just a manual.
No, it's a blueprint. It shows how manufacturing complexity is really the foundation for their strategic business goals. Things like heat treatments are directly linked to duty benefits.
Okay, so let's unpack this manufacturing gauntlet. Let's start with the heart of the bike, the frame.
Right. And we're not talking about basic aluminum tubing here.
No, the sourceless mandatory TIG welding checks, then fatigue tests, vibration, even salt spray testing.
And that's before you even get to the really precise engineering, the specialized alloy treatments.
You mean like the T4 and T6 heat treatments?
Yep.
I also saw something called Aranzam ACK processing and baking.
Exactly. And those treatments, they aren't for vanity. They're about scientifically aligning the metal's internal structure.
Which makes it more resistant to microfractures over time.
Dramatically more. And that's what allows the bike to pass those really stringent European safety standards for long-term fatigue resistance.
That sets a pretty high bar for the hardware. How does that same obsessive attention apply to the power source?
The batteries go through some extreme verification. They mandate a dual-phase BMS, the battery management system, just for overcurrent and short-circuit protection.
But the real centerpiece seems to be this rigorous 9-hour battery aging test.
9 hours, yeah.
That feels like a major bottleneck. Why dedicate that much time to just one component?
Because you're not just checking if it turns on.
Yeah.
You have to verify its efficiency and its temperature consistency across multiple levels of charge.
You mean the state of charge, or SOC, levels?
Right. I mean, a battery could perform perfectly at 80% charge, but then fail miserably at 20% when it's under a heavy load.
So they're verifying reliability across the entire operating lifespan.
Exactly.
But if you're spending 9 hours on one battery, that rigor has to scale up. The document notes a capacity of 30,000 units a month.
With over 450 personnel, yeah.
So how do you perform these, almost hospital-grade quality checks without grinding the entire production line to a halt?
They enforce what they call deep NDT, or non-destructive testing, on all the core components. For the motor assembly, for instance, they mandate 100% stage-wise functionality testing.
100%. You're not talking about statistical sampling?
Nope, 100%. They monitor everything using oscilloscope data.
That seems incredibly inefficient. What does that cost, and how could they possibly justify that?
They view it as liability avoidance. Think about it: a battery, a motor, a controller failure. These are high-consequence events. The cost of a recall or, a big warranty claim, it far outweighs the labor cost of verifying every single unit.
So the test days is basically acting as a predictive failure model.
That's a perfect way to put it.
That makes sense. And I see they have specific checks for displays, too. Continuity, button fatigue, waterproofing.
And even high-pressure testing. And to find those really subtle issues, they do specialized sound and vibration testing on the motors in a dedicated silent room.
A silent room?
Think of it like a mechanic with a stethoscope. Only this room is quieter than a library. They're listening for the faintest harmonic frequencies that might indicate premature wear.
So all of this deep, localized control, it has to boil down to a strategic edge. It has to pay off beyond just customer satisfaction.
Absolutely. And this is the sweet spot where that lab-grade engineering meets smart business logistics. EBOC has achieved over 80% localization across its portfolio.
And crucially, I saw that 61% of the core components, the battery, motor, and controller, are now sourced or made locally.
And that's the key.
So what does that actually mean for the business's bottom line?
Market access.
Yeah.
And cost avoidance. That level of localization qualifies them for the India Country of Origin certification.
Which then lets them secure
0% anti-dumping tariffs in critical markets. It makes their products far more competitive overnight.
And what about for that huge European market? They use the REX system, right?
Registered exporter system.
Yeah.
It's a huge advantage. That system reduces the standard 6% basic customs duty down to just 2.5%.
Because they can self-certify the origin of their components?
Precisely. It speeds up customs and unlocks those duty benefits instantly. That strategic sourcing decision saves them millions.
It's a complete masterclass in marrying engineering rigor and supply chain mastery.
A perfect marriage of the two.
We've talked about these incredibly complex 100% quality checks on every component. But here's something for you to mull over. The document notes the entire vehicle manufacturing cycle time, from start to finish, is 1,981 seconds.
Which is, what, about 33 minutes?
Just under 33 minutes. So the question we'll leave you with is this. How much engineering complexity has to be packed into such a short, defined workflow to maintain that 100% quality assurance target while still hitting that cycle time? That's the real deep dive.